here's the third category of our reactions. Remember, we learn about precipitation reactions, and then we learn about acid-base reaction, and then the third type is the oxidation reduction reaction, or we call it as redox reactions. Okay, we have exposed to loss of electrons and gain of electrons. So oxidation is the loss of electrons and reduction is the gain of electrons. You can remember this as oil rig. Oxidation is loss, reduction is gain. Okay, and then there are two agents. Oxidizing agent gains electrons and is reduced, and the reducing agent loses electrons and is oxidized. A redox reaction involves electron transfer, and the oxidation and the reduction should occur together. Okay, let's see. I'm going to give you an example over here. Let's say you are going to form with sodium and chlorine. You're going to be forming sodium chloride. Okay, so sodium and chlorine, let's say you are going to form sodium chloride. Okay, now the sodium need to remove an electron and become sodium plus 1. So oxidation is a loss of electron and formation of a cation. If it loses an electron, it would be in the product side. And the reduction is the gain. So chlorine will gain an electron that the sodium lost and will become Cl minus. Okay, that's how the sodium ion and chloride ion together form sodium chloride. Now we call sodium, this process, as oxidation because it's a loss of electron. This is oxidation. Okay, and then this is called reduction because chlorine gain an electron. Now sodium can leave an electron or lose an electron because chlorine is there to get that electron. Because of that, we call chlorine as the oxidizing agent. Oxidizing agent. The person who help for the other thing to oxidize. Sodium undergoing oxidation, and we call chlorine as the oxidizing agent. Now, who is undergoing reduction? Chlorine is undergoing reduction. But who is helping sodium to undergo, chlorine to undergo reduction? Sodium. So we call sodium as reducing agent. Reducing agent. Okay. Oxidizing agent, which is in this case chlorine, gains electrons and is reduced. Oxidizing agent chlorine gain electron and it's been reduced. And the reducing agent, which is your sodium, loses an electron and is oxidized. Okay, the person who is not undergoing oxidation is not the oxidizing agent, that's the reducing agent. The item or the atom that's undergoing the reduction is not the reducing agent, that is the oxidizing agent. Okay, now let's look at the redox process in formation of magnesium oxide. Magnesium is in group 2, oxygen is in group 6. So group 2 elements would like to lose 2 electrons and become plus 2 charge, and group 6 elements, the most common ion that they make is negative 2 by gaining 2 electrons. So magnesium give 2 electrons to oxygen. So what is happening to magnesium if it loses electron? Magnesium is undergoing oxidation. What about oxygen? Oxygen is taking 2 electrons. So oxygen is undergoing reduction. Who is the reducing agent? Magnesium is the reducing agent. Oxygen is the oxidizing agent. Okay. and then the transfer of electrons happen. Magnesium will become 2 plus, oxygen will become O2 minus. So this is the ionic compound of magnesium oxide, Mg2 plus and O2 minus. But they were separated as magnesium and oxygen before. Okay, that is the formation of an ionic compound. And then if you have a two covalent compounds, molecules, hydrogen sharing electrons, 2 electrons, chlorine sharing 2 electrons, and they shift electrons to form hydrogen chloride, 2 molecules of hydrogen chlorides, electron distributed unevenly. So this is the molecules of the covalent compound hydrochloric acid. And there are some rules that we use to assign oxidation numbers. For an atom in its elemental form, meaning if you just found an atom, that the same way that you find in the periodic table, their oxidation number is 0, meaning it has not formed a compound if it is by itself. Sodium without forming any compound by itself, carbon, and any element, magnesium, phosphorus, all of those, oxidation number is 0. But there are some molecules that they exist in nature as either diatomic molecules or tetraatomic molecules, or if it is sulfur as sulfur 8, their oxidation number also 0. Oxygen, chlorine, fluorine, bromine, iodine, nitrogen, hydrogen, H2. So they are diatomic molecules. Their oxidation number also 0. Now for a monoatomic ion, oxidation number. Monoatomic ion mean if a sodium is in a compound like sodium chloride, okay, their oxidation number is same as the ion charge with the sign before the numeral. It doesn't matter. For example, if you have sodium in a compound, sodium chloride. Now here sodium is not in the elemental form, it is in the ionic form. So in this case, the group number for sodium is +1. So oxidation number for sodium also going to be +1 in that case. That's what it says for monoatomic ion. Oxidation number is the ion charge. And then the sum of oxidation number values for the atoms in a molecule or formula unit of a compound equals 0. The sum of oxidation number values. Now for example, sodium chloride I have written here. Sodium oxidation number is +1. And then the chlorine, the most common ion chloride makes is +1. Okay, so in a compound, a neutral compound, you take the charges of +1 for sodium chloride plus the -1. So +1 and -1 equals 0. So that's what it says. Compound equals 0. The sum of oxidation numbers values for the atoms in a molecule or formula unit of a compound equals 0. And then the sum of oxidation number values for the atoms in a polyatomic ion equals the ion's charge. For example, carbonate, let's say CO3, carbonate is -2. It has the charge of the polyatomic ion. When you add the oxidation number for carbon and oxygen together, it should equal -2. Let's do some examples and you'll understand it more. Okay? And some more rules for specific atoms or periodic table groups. Normally for group A, group 1A, which is group 1, your lithium, sodium, potassium, their oxidation number is +1 in all the compounds. For group 2A, oxidation number +2. Group 2, you find beryllium, magnesium, calcium, strontium, barium, radium. They are all going to be +2. And then for the hydrogen, hydrogen is in group 1, the first element. Hydrogen could be +1 or -1. If hydrogen is combined with non-metals, like for example HCl, hydrogen combined with a non-metal. So Cl, we know chlorine is -1, group 7. So then with a non-metal, hydrogen would be +1. And then oxidation number would be -1 in combination with metals and boron compounds. So sodium hydride, NaH, with a metal. Now, so hydrogen in sodium hydride is combined with metals. So sodium is in group 1 is going to be +1 in all compounds, group 1. So if sodium is +1, then hydrogen has to be -1, because altogether the charges needed to be balanced and neutral. Okay, so with hydrogen with non-metals, it would be +1. With the metals, it's going to be -1. And for the fluorine, fluorine is going to be -1 in all compounds. And for the oxygen, oxidation number is -1 in peroxides, for example, H2O2. And then oxidation number for oxygen is -2 in all other compounds, except with fluorine. And for the group 7A, group 7 elements are going to be your fluorine, chlorine, bromine, iodine, so those ones. Oxidation number is going to be -1 in combination with metals, like sodium chloride, right? So if you take sodium chloride with metals, sodium is +1, so the chlorine has to be -1, chloride. Combination with metals. And with metals, non-metals also -1, except oxygen and other halogens lower in the group. Because if you have oxygen with chlorine, oxidation number can change. Okay? Okay. Determine the oxidation number of each element in this species. Zinc chloride. So first we need to write how to write the formula. Zinc chloride, ZnCl2. So zinc oxidation number is going to be +2. And chloride is with a metal, so then the chloride, each chloride is going to be -1, one chloride, and there are 2 of those, so 2 times -1, -2. So you are +2 and -2, so overall the zinc chloride become 0. Okay. And then the sulfur trioxide is SO3. Now between sulfur and oxygen, if you go to the previous slide, it says for oxygen, oxidation number -1 in peroxide. Sulfur trioxide is not a peroxide. Okay, if it is a peroxide, it should be said in the formula naming. But it's sulfur trioxide, it's a covalent compound. Okay, and -2 in all other compounds. So then oxygen, we know the oxidation number for oxygen, but we don't know the oxidation number for the sulfur. So oxygen is -2, sulfur we don't know. But we know if you have a neutral compound, when you add the charges, sum of oxidation numbers, it should equal to 0. So you put this as a little math problem. Sulfur, you don't know the oxidation number. And there are 3 oxygens. 3 times 1 oxygen, oxidation number is -2. When you add the sum of oxidation numbers, they should equal to 0. Now sulfur plus 3 times 2 is -6 equals 0. So sulfur minus 6 is 0. So what should be the oxidation number for sulfur? That's going to be then +6. So that's how you find oxidation number of an unknown compound, by looking at the known element. That's the sulfur trioxide. And then for the nitric acid. Okay, so I'll do how to do the nitric acid here. Let me go ahead and erase this part. Let's do nitric acid now. Nitric acid is HNO3 3. It's a neutral compound. So then when you add the oxidation number for individual atoms, hydrogen oxidation number plus the nitrogen plus the 3 oxygen oxidation numbers should equal to 0. Okay, so we are referring to this rule. The sum of oxidation number values for the atoms in a molecule or formula unit of a compound equals 0. Okay, so and then we're going to look at individual ones. Hydrogen here with a nonmetal. So with a nonmetal, hydrogen is +1. And in the rules table, we did not have anything that tells about nitrogen. So it can vary. So we're going to keep it as it is. But we know for oxygen, it was given to us. Oxygen normally is -2, if not in a peroxide. So this is not a peroxide. So that adds up to 0. So then +1 here, +1 plus nitrogen, 3 times 2, -6. -6 times positive, -6 equals 0. So -6 and +1 is -5. So nitrogen is oxidation number +5. Okay, that's how you find the oxidation number for the nitrogen. +5, hydrogen +1, and oxygen -2. Okay, and then let's look at the oxidation number for the dichromate ion. Again, you can refer to your polyatomic chart to find out what is the dichromate ion. Dichromate ion is Cr2O7 -2. And then we're going to refer to the rule that says the sum of oxidation number values for the atoms in a polyatomic ion equals the ion's charge. Now this is a polyatomic ion, and when you add up the oxidation numbers of chromium and oxygen, it should equal to -2, since this is a polyatomic ion, not neutral. Okay, now there are 2 chromium ions plus 7 oxygen. When we add up the oxidation numbers, it should equal to 2. Now between chromium and oxygen, from the rules table, we can find out what is oxygen oxidation number, which is -2. So 2 chromium plus 7 times -2 is 14. So 2 chromium plus 7 times -2 is -14 equals -2. Now then the 2 chromium equals -2, +14. So when you if you want to get rid of the -14 from the left side, if you add +14 to both sides, it will be cancelled. So this is simple algebra. Okay, so then 2 chromium would be -2 plus 14, +12. So then the chromium oxidation number would be 12/2, that is +6. Okay, that's how you find the oxidation number for the individual atoms in a ion or a neutral compound. These are the numbers, and I just showed you how the numbers are obtained. Okay, these are the summary of terminology for redox reactions. Let's say X giving an electron to Y. So then what happened to X? X loses electrons. Okay, if it loses, remember the oil rig oxidation is lost. So if it loses, X is oxidized. And if X is oxidized, it's helping the other one to undergo reduction. So X is the reducing agent. And then X increases its oxidation number. If X was 0, by losing an electron, it would become +1. If it was +1, losing an electron, another one will become +2. So X increases its oxidation number. Now for the Y gains electrons from X. So then Y is reduced, gaining is lost. oil reduction is gaining. Okay, I think I said something wrong. But anyway, oil reduction is gain. So Y gains electrons, so Y is reduced. And then since Y is helping X to oxidize, we call Y as the oxidizing agent. Y is going to decreases its oxidation number because it's gaining electrons. Electrons are negatively charged. If Y was 0 to begin with, by gaining an electron, it becomes -1. If it gains 2 electrons, 0 will become -2. So it decreases its oxidation number. Okay. Okay, so these are the elements in redox reactions. There are some combination reactions. Two or more reactants combine to form a new compound. We can also find decomposition reactions. Single compound decomposes to form two or more products. Z become X plus Y, that is a decomposition. Displacement reactions, there are two types, double displacement and single displacement. AB plus CD giving us AD and CB, or X plus YZ. One is being replaced, so Y is being replaced with X, forming XZ and Y. Okay, and combustion is the process of combining with oxygen. So these are some types of redox reactions, and these are some examples. Combining elements to form ionic compound. So potassium with chlorine forming potassium chloride. So this is a combination reaction. To begin with, potassium is 0, and in potassium chloride, potassium is +1. So 0 to +1, potassium is undergoing oxidation. Chlorine, diatomic molecule, 0, and in potassium chloride, it's -1. So oxidation number decreases by gaining electrons. So chlorine is undergoing reduction. Okay, so since the numbers change, it's a redox reaction. If the oxidation numbers doesn't change, then it would not be a redox reaction. Another one, decomposition of mercury to oxide. So this is mercury to oxide, HgO, and this one oxygen charge is -2, so mercury also +2. You heat it, so oxygen will go away, and then you would end up having mercury. Oxygen become a gas when you heat it. So oxygen gas going to be 0 oxidation number for a gas or a diatomic molecule, and then the mercury by itself, Hg, because this is without combining with anything, elemental form, oxidation number 0. So mercury going from +2 to 0, oxidation number decreases. So mercury undergoing reduction, oxygen undergoing oxidation. -2 become 0. Number increases, which is oxidation. So since the reactants and the products have different oxidation numbers, so this is also a reduction reaction. It's a decomposition reaction. And then this is a single displacement reaction. Displacing hydrogen from water, lithium. So lithium metal, you put a piece of lithium into water. Lithium and water, it's going to form lithium hydroxide and hydrogen gas. Lithium in the elemental form, it is 0 oxidation number. In lithium hydroxide, lithium would be +1 because it's group 1, right? And in water, if you look at the charges, oxygen going to be -2 and hydrogen is +1, right? And then lithium hydroxide also, hydrogen +1 and then oxygen -2. And H2 gas, hydrogen gas, since this is how the hydrogen exists in the nature as a diatomic molecule, that's going to be 0. So the hydrogen is undergoing +1 to 0. So the number decreases. So hydrogen undergoing reduction. And who is undergoing oxidation? Lithium 0 becoming lithium +1. That's the oxidation. What about the oxygen? Oxygen -2, oxygen -2, nothing happens for the oxygen. Okay. And then a copper displacement of silver, another displacement reaction. So this is a copper wire that you have here, and you're going to put it in silver nitrate solution. Okay. So this is the copper wire in the atomic view, and then the silver nitrate. So silver nitrate react with copper to form copper nitrate and silver. You can see that silver is being deposited now. Copper is being used up. So in silver nitrate, silver charge is +1 oxidation number and oxygen -2, and if you do calculate the charge for the nitrogen, that would be +5. And now it's going to form copper nitrate and silver ions, single displacement. Copper ions again going to be +2 copper nitrate, nitrogen going to be +5 and oxygen -2. Silver ions, now it is been formed as an elemental silver, that will make it 0. So silver nitrate is +1 to 0. That is oxidation number decreases, which is a reduction, and copper going from 0 to +2, that is an oxidation for the copper. Okay, another oxidation reduction reaction, which is the displacement of copper by silver. Oh, it is silver is being displaced by copper, the other way around. Silver is being displaced by copper, becoming copper nitrate and silver. Now, based on that activity, if which element can displace which kind of elements, so if you put together, there is an activity series of the metals. So the highest in the activity series are very reactive. So these atoms, so the elements, lithium, potassium, barium, calcium, sodium, they can react with water and then displace hydrogen from water. For example, barium plus water, barium hydroxide and hydrogen gas. Also, they can react with steam, they can also react with acid, or they can do all of these. But if you look at magnesium, aluminum, manganese, zinc, chromium, iron, cadmium, these cannot displace hydrogen from the water, but it needs more energy. So if you use steam, gaseous water, then it can displace hydrogen from water, zinc hydroxide and hydrogen. So these are more active compared to these ones. And then these compounds, cobalt, nickel, tin, lead, they can displace hydrogen from acid, but they cannot displace hydrogen from steam or water. Okay, like this, tin plus hydrochloric acid, tin chloride plus hydrogen gas, and this is where the hydrogen lies. And then we have copper, mercury, silver, gold. They cannot displace hydrogen from any source. They are very unreactive. Okay. Okay. Identify the type of redox reaction. Classify each of the following as a combination, decomposition, or displacement reaction. Magnesium with nitrogen forming magnesium nitride. That is going to be a combination reaction. Right? Combine two things to form this. And then hydrogen peroxide with hydrogen peroxide giving you water and oxygen gas. What is that type? That is a decomposition reaction. Okay. And then we have aluminum plus lead nitrate giving us aluminum nitrate and lead. And that is a single displacement reaction. Okay. And we can also find out what's happening. Let's see, we have magnesium plus nitrogen in 2 forming magnesium nitride. And magnesium normally forms +2 charge. Nitrogen is in group 5, makes -3. So the formula is going to be Mg3N2. And when you balance it, it becomes over here 3 magnesium. So the magnesium by itself, oxidation number 0. Nitrogen by itself, oxidation number 0. In magnesium nitride, magnesium is +2. Magnesium is +2 and nitrogen is -3, oxidation number. So what's happening to magnesium? Magnesium going to magnesium +2. That is an oxidation. Okay. And then the nitrogen going from 0 to N3 minus, number decreases, that is a reduction. So who is the reducing agent? Reducing agent going to be magnesium, because that helps nitrogen to undergo reduction. Reducing agent is magnesium. Oxidizing agent is nitrogen. Nitrogen is the oxidizing agent. Magnesium is a reducing agent. And then hydrogen peroxide. What's happening with hydrogen peroxide? H2O2 decomposed to give you water and oxygen gas. Now remember, oxygen oxidation number is -1 in a peroxide. Hydrogen is +1 and oxygen is -1 charge. So -1 times 2 would make it -2. Hydrogen +1 times 2, +2, making hydrogen peroxide charge as neutral. Okay, so in water, oxygen is -2 and hydrogen would be +1. There are two of those. And then oxygen by itself is oxidation number 0. Now what's happening here? Hydrogen is +1 in our reactant, hydrogen +1 in the product also. Oxygen going from -1 to -2. That is, oxidation number decreases by gaining electron. So this is the reduction. And also oxygen becoming -1 becoming oxygen 0. So -1 becoming 0, oxidation number increases, that is a oxidation. So in hydrogen peroxide, oxygen both undergoes reduction and oxidation. Okay. Reducing agent as well as oxidizing agent is going to be H2O2. And then the next one is a displacement reaction. Aluminum plus lead nitrate. Aluminum plus lead nitrate will become aluminum nitrate plus lead, Pb. It's a solid. Okay, so aluminum is +3, nitrate is -1, so aluminum nitrate. So okay, we can balance it. So aluminum here, oxidation number 0. In aluminum nitrate, aluminum oxidation number, nitrate is -1. So aluminum is in group 3, we'll make it +3. Aluminum is +3. Okay, since nitrate remains as NO3, so we can consider that the oxidation number did not change for nitrogen and oxygen. But if you do calculate, oxygen is negative 2 and nitrogen would be positive 5. Okay, and for here lead oxidation number is plus 2, lead 2 nitrate, right? Lead 2 means lead is plus 2, and then here lead by elemental lead it is 0. Okay, so aluminum undergoing 0 to plus 3, which is oxidation, and then the lead undergoing plus 2 to 0, that is number goes down, which is reduction. Okay, so who is the reducing agent? Aluminum is the reducing agent, and then lead nitrate is the oxidizing agent because it's undergoing reduction. Okay, so that concludes our chapter 4.